So good afternoon to one and all. The strength is very less today. I don't know why. What is the reason? Can anyone tell? Is there any inter-schedule today?
No, sir.
No. Only 15 students are present. Okay.
Maybe some are go for Eastern joining.
Which one?
Eastern company का joining था ना आज.
ऐसे है क्या?
हाँ.
Okay. Okay, no problem. So as we have already started about this voltage fluctuations because of heavy load adding, removing that one. So voltage fluctuations will be occurs by according to the American National Standard Institute C84.1, the voltage should be in between 0.9 to 1.1 per unit. Okay, so the voltage should be 0.9 to 1.1. If it is fluctuation is there, that is acceptable, there is no problem at all. But if it is more than that, means less than 0.9 and more than 1.5, 1.1, that is creates a problems, that one here. So now some people are joining, just a minute. Okay, so according to that, the magnitude of the voltage does not normally exceed the voltage ranges specified by ANSI, that is 0.9 to 1.1 for initial. So if it is rapid variation in that one, suddenly increasing, decreasing, increasing, decreasing in the magnitude of current or voltage, that one we are going to call as a flicker, we are going to call that one. That is called flicker, we are going to call. So the loads that can exhibit continuous rapid variations in the load current magnitude can cause the voltage variations that are often referred as flicker here. Now suddenly the load adding means the load current will be increases over there. So there is a sudden increase in that one, directly it is increasing that one. So that is called, it is create in the voltage variations, that one we are going to normally we are going to call as flicker, we are going to tell that one. Yesterday already we have discussed this point. The term flicker is derived from the impact of voltage fluctuations on lamps such that they are perceived by a human eye to flicker here. They are perceived by a human eye to flicker here. Now you can observe that flicker. Suppose if you don't have any mobile TVs, and that situation, if you sit in one room and switch on the lamp, you can observe the light intensity, it is continuously blinking will be there. So that is because of the flicker only, the variation will be there over there. So to be technically correct, voltage fluctuation is an electromagnetic phenomena, while flicker is an undesirable result of voltage fluctuation in some loads. Actually, it is not acceptable because of this one continuously flicker will occur, then the components will get heat. The heated products means what will happen? The insulator will vanishes over there. If the insulation is burned, then what will happen? The short circuit will occurs. Again, it will create a big issue of that one here. So this is undesirable actually. It is not undesirable. There is no use of that one. This is unwanted. We are going to call that. So according to the International Electrotechnical Commission, that is called IEC standards are there. These standards are there in both first unit and second unit. Actually, they have mentioned. Any one place we will discuss that one. So IEC 6100 for 15. The fourth phase is there. Phase actually the 15th number, that one. So defines the methodology and specifications of instrumentation for measuring the flickering. So when we will go for the fourth phase of the IEC 6100, and that places we are going to discuss what are the methodologies, and specifications of instruments for measuring the flicker. And even the IEEE also had some methods and specifications here. Now So the IEEE voltage flicker working group has recently agreed here. Now, recently they are told that one, it is long back 1992, I think 92, 95, they have conducted that one. So IEEE voltage flicker working group has recently agreed to adopt this standard as amended for 60 hertz power supply. In the US, they have considered that one. So power system for use in North America. The North America frequency is 60 hertz. It is there. So according to the textbook, they have referred for the North America only. This standard devises a sample means of describing the potential for visible light flicker, how the spark will flicker, light flicker through a voltage measurement here. Now we can measure the light flicker through a voltage measurement here. Now we can observe that one and it is going to give here. So the measurement method, it is going to simulate the lamp eye brain transfer function and produces a fundamental metric called short-term flicker sensation. We are going to call that PST, that is called short-term flicker sensation, that is called PST we are going to call. This value is normalized to 1 to 1 to represent the level of voltage fluctuation sufficient to cause noticeable flicker to 50% of the sample observing group here. The 50% of the sample observing group, they are going to normalize it to 1. So this 1, it is going to represent the level of voltage fluctuation actually. For the 50% observing group, they are considering as a sample, it is, there is no effect for 1 if the voltage fluctuation will be 1. But if it is more than 1.1, less than 0.9, on that condition, it is not a normal, it is undesirable, or it will create the problem for the lamp, eyes, it is suddenly continuously blinking, the voltage light is there. So your eyes will also affect, and because of that is the brain, that one also it is affect like that, the transfer functions, and it is going to, they are going to produce the fundamentals here. So another measure called long-term flicker sensation we are going to call. This is a short-term flicker sensation. The long-term flicker sensation we are going to call as PLT. PLT we are going to call, that is PST and PLT. You remember the long form of that one. Short-term flickers, that is a sensation. Long-term flicker sensation, that is 65. So PLT we are going to call, that is called long-term flicker sensation, is often used for the purpose of verifying compliance. Compliance we are going to call, to verify the compatibility levels established by standard bodies used in the utility power contracts here. Now, while anybody, if the voltage substation and all the things for the irrigation development, so that purpose, they are going to, all the things the government will not do that one. It is going to give contract over there. In that one only they will mention, we want to this all substation according to this standards here now. So that one with competitive level, they are going to establish the standards bodies, they are going to establish, and while doing the contracts agreement, they are going to mention or use in the utility power contracts. This value is longer term average of PST samples here. This value, whatever it is there, that is longer term average values of PST, that is called short term samples, longer term values are there. So this is the voltage fluctuations we are going to call. And next we will go for, that is called frequency variation. Everyone, you have, I think, voltage, same thing only, the only small change in the voltage variation, decreases, increases. What is the difference between, can anyone tell, under voltage and voltage sag? See, if the voltage is less than 0.9, that is called, and 0.1, that is called, we are going to call as sag, and voltage is less than the standard, that is called under voltage also. But based on the duration only, we are going to separate that one, which is under voltage, up to 1 minute or less than 1 minute, for 30 seconds, 20 seconds, 2 seconds, 3 seconds, like that. The duration, we are dividing those things. So that is voltage sag and swell we have discussed, voltage fluctuations we have discussed so many things on voltages. Now we'll discuss, we'll go move ahead for the frequency now. Go ahead for the frequency variation. If the frequency variation will occur, what will happen? You are going to consider here. Can anyone define what you mean by frequency? You are in final year. Yes. Can anyone define frequency?
Number of cycle completed in 1 minute.
One
Per unit.
per unit.
Yes. Per unit time, sir.
Per unit time. Okay, very good. Number of cycles per unit time, that is called per second also you can consider here. No, see here, actually when the voltage, what happened? When you go for the frequency variation, the term, this is power frequency variation. Actually here, one per unit you have to mention, that is short term flickers we are considering here now. See here, increasing, decreasing like this, the flicker occurred over here now. Because of this flickers and the frequency will over vary here now. So you consider that, suppose I will tell here, this is one cycle I am going to consider here. One cycle I am going to consider. So from where we are going to get the electricity? Supply कहाँ से आ रहा है हमको? The synchronous generator we are using? Yes or no? So the generator we are using here, this whatever the shaft is rotating here now, if it is cycle one rotation, it is called one cycle we are going to call it. That is one cycle. This one. Yes or no? It is completely depends on the speed of the generator. The frequency will be different, changes here now. If the speed is constant, then the frequency will be constant. When the speed of the synchronous motor will be vary, कब vary हो जाते? When the speed will change, depending on the load. Yes or no? Suddenly by removing the load or applying heavy load, the speed will be decreases, the frequency will increase, decreases over there. By removing the load, what will happen? The speed will increases over there. You consider one cycle over there. Cycle ko consider karo, bicycle. Two members you are sitting in a cycle. One person is pedaling that one, but suddenly one person he will left that bicycle. He will leave that one. Speed will be increases. Like that, the synchronous motor, whatever the speed will changes here now. So load changes means the speed variation will be occurs. So that one it will create a power frequency variation will create over there here. It is completely depends on more load of the particular area or particular line, the load is different here. So the power frequency variations are defined as the deviation of power system fundamental frequency from its specified normal value, that is called 50 Hz or 60 Hz here now. Deviation means it may increase or decrease. This is in the foreign countries. This one we are using 50 Hz. It may be for less than 50 or it may be more than 50. So all of you have heard the power grid? Power grid सुना है क्या? Have you heard the name of power grid? आवाज आ रहा है कि नहीं? हेलो, पावर ग्रिड का नाम सुना है क्या? So some switching stations are there actually. Switching stations we are going to call that one substations. So those switching station work is to the frequency it should have to maintain constant. So actually cycloconverters are there, so many things are there. They are going to use that one to maintain the frequency 50 Hz constant over there. So that one just to maintain the frequency itself on one substations are there here. So if any deviation of the power frequency from the its specified value, so that is called, we are going to call as power frequency variations, we are going to call here. The power system frequency is directly related to the rotational speed of the generator supplying the system here. Whatever the electrical supply system is there, it is completely dependent or related to the rotational speed, whatever rotational speed of the generator here now, generator of the supplying system here now. If there is a slight variation in the frequency, then we can think that one, the generator speed will be vary over there. Okay, so there are a slight variation in the frequency as the dynamic balance between load and generation changes here. The generation it changes or load it changes, then obviously the frequency will vary over there. So they are telling here only slight variation is there in the frequency. That is, as the dynamic balance between, we are balancing the load and generation here. Load and generation we are balancing here now. So that is called generation changes. We are going to call that frequency changes. The size of the frequency shift, whatever it is going to shift from one level to another level, shift, and its duration depends on the load characteristics and the response of generation control system to the load changes here. So whatever the frequency value, it is going to vary for how much duration, base duration, it is completely depends on what? That depends on the characteristics of load, and for that load, how the control system, generation control systems, they are going to operate, how they are going to give the response to there. So that one we are going to consider here. Okay, this is completely depends the size of frequency shift, how much frequency is shifted, and at what duration, for 1 minute, 1 second, 2 seconds, on microseconds, milliseconds, depends. This is completely depends on the load characteristics. That is called how the, what is the load and its characteristics, and for the different load, for the variation of the load, how the generation control system will changes over there. According to that, the value will be depends here now. So frequency variations that go outside of the accepted limit, if the frequency variations go outside of the accepted limit for normal steady state operation, for the normal operation of the power system, can be caused by faults on the bulk power transmission system here. This frequency changes, it is going to affect directly on the transmission system here now. If you are changing the load and all the things in the distribution system, but that will affect to the transmission system also. A large block of load being disconnected, suddenly heavy load is there in a industrial areas, suddenly one area the load is removed here now, being disconnected, or a large source of generation is going off. Suddenly, if any generation unit is going off on modern interconnected system here now, one generator to another generator, one generating station to another generating station, already interconnected systems are there. So always the electrical supply will flow from higher voltage to the lower voltage, it is going to flow over there. So the frequency variations of, where we have stopped, motor connected power system, significant frequency variations are very rare here now. We have already done the interconnection system, so the frequency variation is very rare. Then also the frequency variations of consequences are much more likely to occur for loads that are supplied by a generator isolated from the utility system here now. Whatever the generators we have isolated, we have removed from the generator unit or utility system, those can produce us these frequency variations. In such cases, what we have to do, the governor responds to the abrupt load changes may not be adequate or to regulate within the narrow bandwidth required by the frequency sensitive equipments here. The governor will take decisions that one is may not adequate to regulate that frequency within the narrow band or within the range we are going to call that one. So you understood that. I will tell one. I will take one example here. So here now here one hydropower plant is there. Hydropower plant is there. It is generating, suppose 50 megawatt. It is generating here now. It is generating. So 5 units are there here. 5 units, each 10 megawatts. We are going to use 5 10 into 10. That is called 50 megawatts are there. So these are supplying to some state. One state you are considering Maharashtra state. It is going to supply here. But the required is 60 megawatt is required. 60 megawatt is required. How much we are generating? 10 megawatt. Another 50 megawatt we are generating. Another 10 megawatt we have to take. So other we have to do interconnections here. That is one thermal power plant I will consider here now. Or middle of that one, what will happen? I can use the solar panel. I can use here now. Somewhere we are using solar generator. All these systems are interconnected to one. Suddenly what will happen if it is thermal power plant is there here, it is also generating, suppose 50 megawatt, you consider that one. Suddenly one is goes off here. No, this any problem here and that condition, what will happen here? The load will be increases over there. On that situation, the frequency variations will be more. On that conditions we are going to tell here now. Because the generator suddenly we have applied the load to the generator means it will slow down, and suddenly it is removed means suddenly it is going to increase us over there. So completely depends on the rotational of the generator we have discussed here. So it completes the power frequency, and it is also completes whatever the issues, categories of different issues we have discussed in the previous. I'll show that one. Long 3, 4, 5, 6. Voltage imbalance away. So this all will comes under this category one. See here, the power quality issues are comprised into following category. We have discussed this transients. Transients we have discussed long duration, voltage variations, that is over voltage, under voltage, and sustainable interruptions. We have discussed short voltage variations, that is sag, and swell. We have discussed voltage imbalance. We have discussed waveform distortion, that is DC offset, flicker, noise, and some another two we have discussed in this one. Voltage fluctuation we have discussed just now, and power frequency variations we have discussed now. So only 2 points are left according to your syllabus, that is standards and that was that one MBE curve, CBEME curve, we are going to call that one. Computer Business Equipment Manufacturing Association curves or standards is the left here. So here this transients, long-term variations, voltage variations, short-term voltage variations, voltage imbalance, waveform distortion, waveform fluctuation, power frequency. In this one, these all the things again we are going to discuss in the second unit and third unit. These all are linked with one to another. These all the things are linked with one to another. When we will go for the harmonic identification, on that one, when the harmonics will be producers, what is the voltage fluctuation, what is the flicker, and all the things again once again it will comes over there. So the transients and harmonics, what is the difference, we are going to discuss in the second unit. Okay, this almost this unit is only 2 bits are left in this unit. These are all the things we have already discussed. Voltage fluctuation, all this. Okay. See, the international standards are standards of power quality. The next point or next bit of the worry is international standards for power quality here. International standards of power quality. Actually, some IEEE standards are there. So, and IEC standards are there. We are going to discuss that one. We are not going to discuss much more about that one. Just what are the standards are there here now. In the first unit, there is no much details about that. But in the second unit, actually, they have mixed here. Here, they have given the title that International Standards of Power Quality. And in the second unit, they have mentioned IEEE and IEC standards. So IEEE and IEC standards are international standards only. So you have to discuss those only here now. So according to IEEE, 1, 2, 3, 4, 5, 6, 7, the IEEE standards they have produced here now. So all these are related to the power quality. The field of that IEEE standards we have mentioned here now, but inside that, what are the standards number 1, 2, and all the things we are not taking here now. Just we are mentioning the IEEE power quality standard here now. That is the Institute of Electrical and Electronics Engineering. It is one standard they have maintained here. Second one, IEEE power quality standard, that is called International Electrotechnical Commission. That is called, this is also IEC only here. Electrotechnical Commission, that is called IEC standards we are going to call it. This one we are going to discuss in detail here now. IEC standards here. International Electrotechnical Commission. The third one, that is IEEE power quality standards here now. For the standards of the power quality, semiconductor equipments and material internationals are there. What are the semiconductor equipments we have to use, we should not use, and why we are not using, like all the things they have mentioned in the this one. Next one, IEEE power quality standards. Here also power quality standards, here also power quality standard. This is semiconductor equipment, but here that is International Union for Electricity Appliances here. Now, for all appliances, they have made one union that is called International Union, that will comes under the IEEE power quality standards. It is going to come. So the International Union for Electricity Appliances we have called here. Next one, IEEE standard. The number we have mentioned here, 519 into 1992 here. Up to here from old, that is 1992, they have formed this one. That is what it is, the IEEE recommended practices and requirements here now. Practices and requirements for harmonic control in electric power system. Actually, harmonics will come in the second unit. So it is applicable for the second unit. The one they have mentioned in that there also. That is 1992. Into 1993, what they have mentioned, that is IEEE recommended practices for electrical power distribution and industrial plants here. They have mentioned one more standard, that is IEEE standard, that is 1412 1993 here. Next, in the 1995, actually power quality monitoring system they have developed here now. Previously, that is only for the harmonics control and electrical power system. Second one, electrical power distribution and industrial plants they have found here now. And in the year of 1159 to 1995, the IEEE has recommended that the practice for monitoring electrical power quality here now. How to monitor the electrical power quality? They have mentioned some standards in IEEE 1159 to 1995 standards here. So these many standards here, IEEE standards we have. That one, any one we can use. Which one it is? Especially this one, it is related to the electrical power quality. And this one, IEEE, where it is second one, that is Electrotechnical Commission standards are there. This one we are going to discuss here now. The second one, yeah, which is suitable for this power quality here now. That is called IEC, International Electrotechnical Commission standards here. International Electrotechnical Commission standards. Just a minute. Okay. So before starting this one, 29 students are present. So as per your various TPO coordinator, he has told you people to upload the good quality of photo with Blazor actually. Is it audible? आवाज आ रहा है क्या?
Yes, sir. Yes.
अपलोड
Yes, sir.
किए क्या?
Yes, sir.
You have uploaded, you are telling yes. Other people's please not giving the response means those anyone ऐसा कोई है क्या? अभी सर का कॉल है, वो बोल रहे that is needed urgently, आपका बैनर बनाने वाला है. So for that reason they are asking that one Blazor photo you have to upload by filling that Google form. कोई है कि अभी तक नहीं फिल किया बोल के ऐसा? मंगुस्कर. Is there anyone? Blazor ब्लेसर हो गया क्या? ठीक है. How many of you placed ये Vedant Jadhav? Are you there? Jadhav Vedant? No. Khatare Ankita? Ankita Khatare? Saurabh Mule? Mule Saurabh? Payal Salgare?
Sir.
Have you filled that form? आप
Please.
वर्जियो में प्लेस हो गए ना?
यस सर, पर मैंने ज्वाइन नहीं किया वो कंपनी.
ज्वाइन होने दो ना होने दो, बट आपका ऑफर लेटर तो लिए ना?
यस सर.
Then the question is very clear. All the placed student he has mentioned.
फील करती हूँ सर मैं.
Do it as soon as possible. Shraddha, you have done that one. Gayatri Ekatpure, Kiran Lamkane, Shivam Solanki. प्लेस हो गए बोल के क्लास नहीं कर रहे क्या वो लोग? ठीक है, we'll see that one. I'll discuss with higher authority then. Only out of 66, 28 students are present. Other people, this is a very horrible thing. Okay. So do that one, all of you. We has already placed you people, you fill that Google form and submit it. That data is needed on urgent basis. Okay, next we will go for the second one, the IEEE standard of that is called power quality standards here. IEEE power quality standards. That one it is going to that International Electrotechnical Commission it has formed here. No, according to that IEC International Electrotechnical Commission standards here. It has formed some 6 parts are there here now. 6 parts are there. Each 6 parts we are going to discuss in this class here. So the International Electrotechnical Commission that is called IEC currently working with in headquarters in Geneva here now, Switzerland area. Here, the IEEE standard that is IEC standards it has formed based on the power quality purpose here now. So the headquarters is there available in Geneva, Switzerland. It has defined a category of electromagnetic compatibility here now. That is for which is required for the electrical power system, power quality here now. That is EMC, electromagnetic compatibility standards that deal with power quality issues here. It has formed some standards here now. It defined the some standards here now, which is going to deal with power quality issues here. So the term electromagnetic compatibility includes concerns for both radiated and conducted interference with end-use equipment here. It includes that both radiated and conducted interference here now. So the IEC standards are broken down into 6 parts here. Whatever the total part is there, that is broken into 6 parts, which is related to the general words are there. So general we have considered, which is related to the environment, that is environment we have considered. For the limits and standards, that is called limits we have considered. For the testing and measurement companies, that is testing and measurement techniques we have considered. Who is going to install, that is called installation mitigation here now. And last one, miscellaneous. If any others are there for that one, it has formed some miscellaneous, that is standards are there. These things we are going to discuss now. First one, the part 1 is that the part 1, what it is going to show, that one here now. So these standards deal with general considerations here. It is going to deal with general considerations. Example, it may be issues, importance, some introductions, fundamental principles, definitions of voltage sags, well, under voltage, over voltage, what is the sustainable interruptions, inter-interruptions, transients, what are the different types of transients, like that. It is going for general considerations only. It may be definition to the introduction, or it may be fundamental principle, or rationale, definitions, terminologies. This all includes in this one here now. So they can also describe the applications and interpretation of fundamental definitions and terms here. It is going to interpret application and fundamental definitions of the terms here now. So their designation number of this general part here, no, general instructions are fundamentals, the standard IEC here, no. So its designation number we are going to call, that is called IEC 6101X here, no. That is, this one is 6000, it is a standard, all 6000 IEC standard is nothing but, okay. And one is indicate part 1, that is indicate part 1, it is going to indicate, and X is nothing but in this part 1, it is related to the fundamental principles, that is 1, introduction, that is 2, rationale, that is 3, definitions, that is 4, terminologies, that is 5, like that. Again, it is subdivided into as per the policies over there here. So that is, this is the designation number of the IEC part 1, that is called general here. Next we'll go for the environment here now. In the environment, what we'll do, the standards define the characteristics of the environment here. This standard, it is going to define the characteristics of the environment, where the equipment will be applied here now, where we have applied the equipment. See, previously the motors and all the things we are keeping without water. Now in the agriculture field, you can observe that one. Submergible waters are there, pumps are there. They are going to put in the water itself. Inside the bore, we are going to put that one. Inside the well, we are going to put that one. So nothing will happen. So that where we have applied that equipment, that the characteristics of that environment, it is going to define here now. So that is called part 2 of the IEC standard, that is environment we are going to call here. The classifications of environment, how the environments are classified and its compatibility levels, we are going to define by using a IEC standard, that is called environment here, no, part 2 here. So its designation number is again IEC 61,000, that is part 2 environment, and it is that one. First one will be, it is equipments applied here now, and classifications of environment, compatibility levels, like that 1, 2, 3 we are going to use this. समझ में आ रहा है क्या? कुछ समझ में आ रहा है क्या नहीं? बोलो सर, पूछो मत, ऐसा बोल. Okay. So third one, that is called limits here now. First one is general, second one is environment, third one is the limit. Every devices have their own limits over there. There are limits are there. So these standards define the permissible levels of emissions here now that can be generated by equipment connected to the environment. They set numerical emission limits and also humidity limits here. What are the numerical emissions are there and how the humidity limits are there? It is going to set that one here. Every device. Yes. Roll number 13. Roll number 13, are you there? Kate Revati. What is the time now? Now you are joining. I will not give attendance. Okay. So it is going to set the emission limits, humidity limits it is going to set, and its designation number they have written as that is IEC 61000. This is the third part. In that one again it is the emission limits or immunity limits. In that one again some different emissions are there, different immunities are there, different numbers it is going to consider. This X is nothing. So third one is limit. The fourth one is testing and measurement techniques here now. It is going to define the standards of, or it is going to provide the standards for testing here now. We can consider a transformer over there. Single transformer, you consider single phase transformer. What are the different testings we are going to do in a single phase transformer? Different testing methods of single phase transformer. Anyone? Will not give the answer. So have you heard the name open circuit test, short circuit test, insulation
Yes,
test?
sir.
Yes. Blocked, that is for the motors we are going to open circuit, short circuit. Okay. That one we are going to consider on load, applying the load also you can do that one. Okay. Different types of testings are there. Those testings are decided by these standards only here now. They will decide which testing we have to do and what is the procedure for that test. They are going to provide all the details here now. That is called testing and measurement techniques we are going to consider. These standards, what they are going to do, these standards will provide the detailed guidelines here now. These standards, they will provide the detailed guidelines for measurement equipments and test procedures. How to conduct the test, its procedure, and which type of test we have to conduct, that one also they are going to provide here now. Test procedures to ensure compliance with the other parts of the standards here now. We have to match the other parts of the standards here now. So this designation number is IEC 61004 and X here now. That is called 4 is nothing but that is fourth one, testing and measurement techniques we are going to consider. We are going to consider here. So this is how we can do the testings of one. Suppose if you after the completing your engineering, you want to start a startup company, that is transformer manufacturing company, you have to start. First you have to, what you have to do, you have to consider place, you have to select that one. Okay, these many restrictions are there. So these many engineering colleges are there. They are directly they are starting that one. No, they have served their standards according to AICTE standard. This much classroom area should be there. These many students should be there. These many equipment should be there. These many staff should be there. Like that, the testing, once the product is developed, then these many testings you have to do. Which type of equipment it is and what are the testing methods. Once it is okay, then it should have to ISO registration, international standards. It should have to register for that one. We have to get the stamp of that one. Like all the so many methods are there. So those all the things they are providing here now. So total overall IEEE standards I am telling here now. But here for the testing and measurement techniques, this will provide the measurement techniques. What are the different techniques for the measurement? And it is going to provide the test procedures. It is going to provide. That is fourth one. The fifth one is now installation and mitigation guidelines here. These standards, what they are going to provide here now, they will provide a guidelines for the installation where we are going to do the application side here now. I want one mobile for my use. I want my mobile here now, one mobile. I will purchase that one. They will give us some instruction that one like this. You have to operate, check it, switch on it. You have to add your email ID. Like that in the electrical system, the guidelines it is going to provide in application of equipment such as the each equipments, whatever the earthing should be there, cabling of electrical and electronic system for ensuring electromagnetic compatibility. You know, you should have to do the cabling here now among electrical and electronics apparatus or systems here. They also describe the protections concepts for civil facility against the high altitude electromagnetic pulse, that is called HEMP we are going to call, that is high altitude electromagnetic pulse due to high altitude nuclear explosion here. The nuclear explosion should be there. For that reason, they are going to tell that one high, we have to provide the protection against the nuclear explosion and all the things here now. So while doing the installation, and if any problems are there, we have to mitigate those problems. So they are going to provide this IEC PBUS, IEC standards. They are going to provide that one, the guidelines they are going to provide for the installation as well as for the protection purposes they are going to provide. So the designation number of this one is IEC 6100. That is 5 is the part 5th, and the number we are going to provide the only installation guidelines or protection, and based on that one the numbers you can do that one. X is 1 2 3 4, again it will start the sub numbers out there. So the last part of this IEC standard, that is miscellaneous, we are going to call. These standards are generic standards defining immunity emission levels required for the equipments in general categories or for specific types of equipments here. Miscellaneous means other than this all. General we have discussed, environment we have discussed, limits we have discussed, testing, measurement, installation, mitigation guidelines here. Other than that, and the etc. we are going to tell like that. Some emissions, immunities, levels, equipment wise, we are going to discuss that standards are they have provided here. That is called miscellaneous. We are going to call that. That is miscellaneous here. Next one, IEC standards relating to harmonics here. Actually, harmonics part is there in the second unit here now. So we'll discuss, you will understand in the second unit this one. So IET standards, IEC standards relating to harmonics generally fall in part 2 and part 3. So harmonics will part, what is the part 2? That is environment. Part 3 is nothing but limits here now. So these harmonics, it is going to fall in environment and as well as the limits it is for. So unlike the IEEE standards on harmonics, where there is only a single publication covering all issues related to harmonics here. Only one single issue is there, single publication is there, which will cover all the issues it is going to cover here. So IEC standards on harmonics are separated into several publications here. For the harmonics IEC, it has several publications are there. There are standards dealing with the environments and limits, which are further broken down based on the voltage, current levels. These key standards are as follows here. See here 6100-2-2 is that here. This is the second part. Second part is which one? Environment it is going to come here. Here the third is there. Third may again second is there, and that year of that they have mentioned, in which year they have mentioned, given the guidelines for this standards here now, that is 1993. Here 2000 they have given here 1998, here 1996. This is third one is indicates that is environment. Part 3 is part 3 is limit, part 2 is environment here. So these many standards they are going to provide IEC standards. All 6 parts are there. That is first one is general, second one is environment, third one is limit, fourth one is installation and measurement, fourth one is testing and measurement, fifth one is installation and mitigation guidelines, sixth one is miscellaneous here. So these many standards are there. Same standards we are going to discuss in the second unit. Same standards are there. Here only international standards they have mentioned. The second unit they have mentioned IEEE and IEC standards they have mentioned here. There, IEC standards they have mentioned over there. So both are same only. There is no much difference of that one. So the next only one bit is left to complete the first unit, that is called CBEMA and ITI curves are there. We'll discuss in the next class. This part we'll discuss in the next class here. Okay. रोल नंबर 2, 4, 7, 10, 12, 13, 16, 17, 18. Huh? Yes. जोर से बोलो, I don't have time. 19, 23, 29, 30, 31, 34, 35, 36, 37, 41, 42, 44, 45, 47, 48, 49, 50, 54, 55, 58, 61, 60, 65, 66.
65.
Present, sir.
Yeah, okay, present. Next,
57.
57 present है ना? 57 कब बोला मैंने? 56, 57 present है. Only who was absent I have called their number.
65 sir present.
65 present है, ठीक है.
52, sir.
52, ठीक है. Next, roll number 1, 2, 4, 7, 10.
Present है sir. Roll number 1.
1 present है ना? Okay, 2, 4, 7, 10, 12, 13, 16, 17, 19, 23, 29, 30, 31, 34, 35, 36, 37, 41, 42, 44, 45, 47, 48, 49, 50, 54, 55, 58, 59, 60, 61, 62, 64, 66, 66. Okay. So I think all are absent only. For that reason, there is no. So we'll continue in the next class. We'll stop here.
Sir, 26 present.
26 कब बोला मैंने? रोल नंबर नहीं बोला ना, 29 बोला है मैंने. 23 and 29 डायरेक्टली. 24, 25, 26, 27, 28 प्रेजेंट है, ठीक है.